Okay, let's take a look at section 3.5, solving equations and inequalities with absolute values. Now, first thing we'll take a look at is our absolute value equations. And this says if you got something inside an absolute value equal to something else. Now the absolute value has to be by itself on the left side, nothing in front of it, nothing after it. Then you drop the absolute value, you set it equal to positive the other side, you drop the absolute value and you set it equal to negative the other side. For example, this is number 14 on page 285. I got the absolute value of x minus 7 is equal to 5. Now notice that the absolute value is by itself on the left side. There's nothing in front of it, there's nothing after it. Whatever's inside your absolute value is going to be your P, and whatever's on the other side will be your Q. Now your formula says you're going to plug it into P is equal to Q, and you'll plug it into P is equal to negative Q. So everywhere I have a P, I'll plug in x minus 7, and everywhere I have a Q, I'll plug in 5. So I got x minus 7 is equal to 5, and x minus 7 is equal to negative 5. And then we solve like normal. These are linear equations. So I'll take negative 7, move it over. So we got x is equal to 5 plus 7, or x is equal to 12. And on this one, I'll take the negative 7 over. And we got x is equal to negative 5 plus 7, or x is equal to a positive 2. And those would be our two answers. Now in some of the problems, you may have to work at getting the absolute value by itself first, like number 23 in that same section. We have the absolute value of x plus 3 minus 2 is equal to 8. Well, again, we have to get the absolute value by itself. So I'm going to take this negative 2 and I'll move it over to the right side. Remember, when you move anything across the equals, the sign changes. So negative 2 becomes a positive 2. Eight plus 2 is 10. And now it's in the right form. We got the absolute value of something is equal to something else. Now, whatever's inside of our absolute value will always be our P, and the other side will always be our Q. And our formula says we're then going to plug it into P is equal to Q, and P is equal to negative Q. So everywhere I have a P, I'll plug in x plus 3, and everywhere I have a Q, I'll plug in 10. So I got x plus 3 is equal to 10, and x plus 3 is equal to negative 10. Now I'll get the x by itself, so I take these 3's and move them over. And we got x is equal to 10 minus 3, or x is equal to 7. And here I take the 3 over, becomes a negative 3. And we got negative 10 minus 3, which gives us negative 13. And those would be our two answers. Now, I do see some oddball cases. There's not a whole lot of oddball cases. Number 6 is one of them. We got the absolute value of x is equal to negative 3/5. If you have the absolute value by itself, nothing in front of it, nothing after it, and you got the absolute value of something is equal to a negative number. Remember, absolute value's only purpose in life is to make whatever's inside positive. So when you're asking when is it equal to a negative number, it's never equal to a negative number. So your answer will be no solution. Now you have to be careful on that. Let's see. Number 25. I won't actually finish it, but I'll start talking about it. We got the absolute value of 3x plus 1 minus 4 is equal to negative 1. Now you might look at this problem and say, well, it's equal to a negative number. And you said if it's equal to a negative number, it's automatically no solution. But notice that the absolute value is not by itself. I need to get this negative 4 and move it to the right side. Basically add 4 to both sides. Now when I do that, the negative 4 becomes a positive 4. And then we get the absolute value of 3x plus 1 is equal to negative 1 plus 4, which is 3. Now at this point, it's not equal to a negative number anymore. So make sure the absolute value is by itself before you claim it's a no solution. This one, you can then go through your formula. This would be P, and this would be Q, and then you plug it into P equals Q, and P is equal to negative Q. I won't finish that since I go and get a room here, but that's actually a regular problem. Now there's one other oddball case, and I'll mention real quickly. Let me clear this off. Now I'll look for one where I guess 12 is it. Okay, we got the absolute value of 6x is equal to 0. Well, it fits our form. We got the absolute value of something is equal to something else, so whatever's inside of our absolute value will be our P, and the other side will be our Q. And our formula says we got P is equal to Q, and we got P is equal to negative Q. But if I were to plug that in, we would have 6x equals 0, and 6x is equal to negative 0. But positive 0 and negative 0 is just 0. So this gives us 6x equal to 0. Divide both sides by 6. And you end up with just x equals 0. Now that'll always happen whenever you have the absolute value by itself and you got it equal to 0. You never need to set it to equal to positive and negative 0. You just simply set it equal to 0. Because positive 0, negative 0 is just 0. Now the second thing in this section is absolute value inequalities. So let's talk about those. And we got two cases. Case 1, we got the absolute value of something is less than something else. If you got it in this form, then you can rewrite it as negative Q is less than P is less than positive Q. Now our second case, if you got the absolute value of something is greater than something else, then you can rewrite it as P is less than negative Q or P is greater than positive Q. Now let's take a look at some examples. Let's look at number 45. 45 says we got the absolute value of x plus 8 is less than 9. Same section. Now these forms have to have the absolute value by itself on the left side. When I say by itself, there's nothing in front of it, there's nothing after it, you just simply have the absolute value of something. And when you do, then whatever's inside your absolute value will be your P, and the other side will be your Q. Now this one, specifically the less than case. The less than case is case 1, which says after we identified P and Q, we're going to plug it into this formula. So you got negative Q is less than P is less than positive Q. Now everywhere I have a P, I'll plug in x plus 8, and everywhere I have a Q, I'll plug in 9. So I got negative 9 is less than x plus 8 is less than a positive 9. Now our goal is to get the x by itself, so I'm going to take the 8 and move it over to the other two sides. When you take anything across your inequality symbol, the sign changes, so the positive 8 becomes a negative 8. Negative 9, negative 8 gives us negative 17, it's less than x, and 9 minus 8 is 1. They say write the interval notation So these would be negative 17 to 0, because it's between these values. And I put parentheses because there's no line underneath the inequality symbols. And no line underneath means you automatically put parentheses. Graph-wise, parentheses on negative 17, parentheses on negative 17, parentheses on the 1, parentheses on the 1. And that'd be our graph. Now let's look at number 46. We got the absolute value of x plus 6 is less than or equal to 10. Now it's not quite the same. It's not this is less than or equal to. Now books will never give you all four formulas, but it's implied. If you have a less than or equal to, it's the same formula. The difference would be is if I have a line underneath this inequality, then I also put lines underneath these. So this is again case 1. The absolute value is by itself on the left side. So what's inside will be our P, and the other side will be our Q. And our formula says we got negative Q is less than or equal to P is less than or equal to positive Q. Now everywhere I have a Q, I'll plug in 10. And everywhere I have a P, I'll plug in x plus 6. So I got negative 10 is less than or equal to x plus 6 is less than or equal to a positive 10. Now our goal is to get the x by itself in the middle. So I'll take these 6's, or the 6, and move it over the other two sides. So it becomes negative 10 minus 6 is less than or equal to x is less than or equal to 10 minus 6. Which gives us negative 16 is less than or equal to x is less than or equal to 4. Now since it's between two values, this will go from negative 16 to 4, and bracket on both of them because there's a line underneath your inequality symbol. Now graph-wise, bracket on negative 16, bracket on negative 16. Bracket on the 4, bracket on the 4. And then we shade inwards since they both open inwards. And those would be our answers. I didn't write down which one that was. That was number 46. I don't think I wrote it down. Okay. Let me clear those off. Then we'll look at another example. The greater than case. Let's look at 48. Got the absolute value of x plus 6 is greater than 10. Now notice the absolute value is by itself on the left side again. There's nothing in front of it. There's nothing after it. And so this will be case 2 because this symbol is a greater than. And this is a greater than formula. And that says we're going to identify P and Q. So P is whatever's inside your absolute value. Q is the other side. And this is the formula. Now that OR does not mean you can plug into one or the other. You have to plug it into that entire formula. So everywhere there's a P, we'll plug in x plus 6, and everywhere there's a Q, we'll plug in 10. So we got x plus 6 is less than negative 10, or x plus 6 is greater than a positive 10. Now we want to solve each one of these separately. So I'll take the 6 and move it over. So we got x is less than negative 10 minus 6, or x is less than negative 16. On this one, I'll take the 6 over. And we got x is greater than 10 minus 6, or x is greater than 4. And there's still that or between them. Now let me show you how that looks interval notation-wise. X is less than negative 16. That's going to negative infinity. Now infinities always have parentheses, and the negative 16 will have a parentheses because there's no line underneath the inequality. Now x is greater than 4. Greater than always goes to positive infinity, so this would be 4 comma positive infinity. Infinities always have parentheses on them. And there's no line underneath the inequality, so this will also be a parentheses. And then you connect them with a union, and that would be our interval notation. Now graph-wise, parentheses on negative 16, parentheses on negative 16. You shade whichever way it's opening. It's opening to the left, so I shade the left. Now in this one, parentheses on the 4, parentheses on the 4. And it's opening to the right, so I shade to the right. And now would be our graph. Okay, let's skip over to 4.1 and talks about polynomial functions and modeling. Let me grab a drink here. Okay. Some definitions. Remember, a variable is a single letter. A term is a number times a variable, and I'll put an S on there because you can have more than one, or a variable times a variable. Now I'll put an S on it to indicate you can have more than one. Examples of that: 3 would be a term. It's a number. 7x would be a term. It's a number times a variable. Now 8x squared would also be a term. And you're saying, well, you don't say anything about exponents. Well, a number times a variable, well, that's number times a variable, and there's an S on there. 8 times x times x. There's nothing saying that the variables won't repeat. Or a variable times a variable, you could simply have like x to the third. And x to the third is x times x times x, variable times a variable. So those are all examples. Now we have a monomial, which is one term. We have a binomial, which is 2 terms. We have a trinomial, which is 3 terms. And then what we're specifically talking about in this section is a polynomial, which is 1 or more terms. Now we have something called a degree. And this is your largest power of x. It's actually a little bit more than that, but that's the best definition for college algebra. If you took intermediate algebra, you know you can have a mixtures of x's and y's, and you have to do something different to get the degree. We have something called standard form. This is where your terms are arranged from largest power down to smallest power. And everything I'm typing in here relates specifically to polynomials, so that's given. You have a coefficient, which is the number in front of the x, in front of the term, sorry, number in front of the term. For example, my example's up here, the 7x, the coefficient will be 7. The 8x squared, the coefficient will be 8, the number in front. The x to the third, the coefficient will be the invisible 1. And the weird one, the coefficient of 3 is 0. There is no x. So that's just our coefficient. Okay. Now we have the leading term. This is your first term when the polynomial is in standard form. You have your leading coefficient, and this is the coefficient of the leading term. So maybe I could spell. And I'm just going to refer to this as coefficient. We also have degree, which is our largest power of x. And I know I got that up above, but I'm putting it here for a specific reason. Okay, the next topic is the leading coefficient test. Okay, now we're talking about degree and coefficient. Leading coefficient test tells you what is your graph doing, polynomial, as it goes clear to the left and clear to the right. So it's your end behavior. Well, you can have an even degree. That's one possibility. Or you can have an odd degree. That's another possibility. You can have a positive coefficient, or you can have a negative coefficient. Okay, come on. It's my wife telling me my house is on fire, I guess. What was I saying? Do I need to take shelter? I love the smell of fire or smoke. So let me open the window a little bit. Okay, to start passing out from the smoke. Okay, back to what it was. Even degree, positive coefficient. This is going to be up to the left, up to the right. If you have an odd degree and a positive coefficient, it's down to the left, up to the right. If you got a negative coefficient and even degree, it's down to the left, down to the right. And if it's an odd degree and negative coefficient, it's up to the left, down to the right. Okay, well, let's see what in the world this means. So let me clear this off. This is on page 309, section 4.1. Okay, and I'll take a look at page, I think the first ones are pretty obvious if there's any homework dealing with that. Let's look at number 11. We got negative 3x to the third minus x plus 4, and f of x is equal to that. And, okay. Now this is in standard form. Terms are arranged from largest power down to smallest. The only term we look at is the first term, the leading term. So all the rest of those we don't worry about in terms of determining end behavior. And they ask us to select one of the 4 sketches to describe the end behavior. Okay, we got a negative coefficient, we got an odd power. Negative coefficient, and we got an odd degree. That says up to the left, down to the right. Up to the left, down to the right. And that would be our answer. Let me take a look at another one. Number 12. We got f of x is equal to 1/4 x to the fourth plus 1/2 x to the third minus 6x squared plus x minus 5. Same instructions. We want to determine the end behavior. It is in standard form. The only term we're going to look at is the first term. All the rest do not matter. And it's got a positive coefficient, and it's got an even degree. So even degree, positive coefficient, we're going to go up to the left, up to the right. So our graph is going to go up to the left and up to the right. And it looks like that choice right there. Now this doesn't tell you anything about what's happening in the middle. All it tells you is it goes clear to the left, it's going up. As it goes clear to the right, it's going up. Okay, so let's take a look at one more of those. Number 19. We got f of x is equal to negative x to the 6 plus 2x to the 5th minus 7x squared. And it wants us to match the function with one of the graphs given. And we're going to use the leading coefficient test to do this. They call it leading term test, but again, we're only going to look at the first term. All the rest do not matter. So we got a negative coefficient and an even degree. So even degree negative coefficient tells us it's down to the left, down to the right. So down to the left, down to the right. So I'm looking for one of my graphs that's down to the left, down to the right. And that looks like it's C. So that'd be our answer. Now the next topic is finding zeros. So let's review a little bit on that before we take a look at a couple of problems. Let me clear this off. Just in general, to find a zero, so finding zeros of a polynomial, your first step is to set the polynomial equal to 0. Then your second step is to solve. And that's how you find your zeros. Now sometimes it's not so easy to solve, but that's how you do it. Let's take a look at problem number 28. And we've got f of x is equal to x plus 5 to the third power, x minus 4, and x plus 1 squared. Now, the instructions say find the zeros of the polynomial function, so we'll start with that. And we said over here, to find the zeros, you set the polynomial equal to 0 and you solve. So I got x plus 5 to the third times x minus 4 times x plus 1 squared equal to 0. Okay, now how we'd solve this is you'd factor this, which we already have, and then by the zero factor property, we'll set each factor equal to 0. So we'll set x plus 5 equal to 0, we'll set x minus 4 equal to 0, and we'll set x plus 1 equal to 0. Now notice I'm ignoring the powers for now. I'll come back to those. And solve these. So we get x equals negative 5, x is equal to 4, and x is equal to negative 1. These would be our zeros. And what that means is if I plug any one of these back in to my original function, that'll cause that to equal 0. Now the second thing it's asking for is the multiplicity. Multiplicity basically means how many of them. So how many? What do I mean by that? Well, up here, remember we had x plus 5 to the third power. This power here tells us how many we have. So that means we got 3 of these because our power is 3. The x plus 1, we got second power, so that means our multiplicity is 2. Now there is no power on the x minus 4, but if I were to put one there, we could put a first power, which means this would be a multiplicity of 1. Now they don't really ask anything about that in this section, but multiplicity tells us whether the graph touches or crosses your x-axis. And that helps in terms of your graphing. Let's take a look at another one of those. One of them we have to actually factor. Let's take a look at number 42, I believe. We've got f of x is equal to 3x to the third plus x squared minus 48x minus 16. And the same instructions. We want to find the zeros. Well, first thing I'll do is I'll set that equal to 0. And I want to solve it. Well, this will factor, and this will factor by grouping. The reason why I say grouping is because we got 4 more terms. So our group first 2 terms together, or group last 2 terms together. First 2 terms have an x squared, and that leaves us 3x plus 1. The second group has a negative 16 in common. They're both divisible by 16. And remember, if your first term is negative, you always factor out a negative. And that gives us 3x plus 1. Now our goal with grouping was to get this parentheses the same as this parentheses. So I'll factor out a 3x plus 1. And that leaves us x squared minus 16. Now x squared minus 16, two terms with minus between it, that's a difference of two squares. So this factors as 3x plus 1 times x plus 4 times x minus 4 is equal to 0. So now we're at basically the same point where this first problem was, where everything's factored. So the zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set 3x plus 1 equal to 0, I'll set x plus 4 equal to 0, and I'll set x minus 4 equal to 0. So here I'll take the 1 over, it becomes a negative 1. Divide both sides by 3 and we get negative 1/3. Here I'll take the 4 over and it becomes a negative 4. And here I'll take the negative 4 over and it becomes a positive 4. And these would be our zeros. Now for our multiplicity is whatever power is on these up here. Now if we were to put a power, they're all to the first power. So our multiplicity all the way across is 1. Now your degree, remember, is your largest power of x. If you add together your multiplicities, that should give you your degree. 1 plus 1 plus 1 is 3, which matches our degree. Now, let's take a look at doing these on the calculator. Let's take a look at, let me erase this, and we'll take a look at number 44. And we got f of x is equal to x to the third plus 3x squared minus 9x minus 13. And the instructions say using a graphing calculator, find the real zeros of the function. Approximate the zeros to 3 decimal places. Well, we're finding zeros, so we're going to set it equal to 0. And let's talk about finding zeros on T83, T84. Finding zeros on a T83, 84. Step 1. Put your polynomial on Y1, 0 on Y2. Step 2. You're going to do a second trace. You're going to choose intersect. You'll do inner on first curve. You'll do inner on second curve. Then you'll input an x value close to your answer and press enter. Step 3. If you have decimals, then you're going to do a second mode to exit out, and then you'll do math, enter, enter. And step 4, repeat if necessary. Okay, so those will be our instructions. So we're going to go to our calculator. I'm going to go to y equals. This tells us, this tells us to put our polynomial y1, 0, and y2. So I'm going to put x to the third, so I'll do x carried 3 plus 3x squared minus 9x minus 13 on y1, and then I'm going to put 0 on y2. This process does not work if you don't put 0 on Y2. Then I'm at step 2 now, right here. We'll do second trace. So I'll push my second button and then my trace. Now we want to choose intersect. So you can down arrow to it and highlight it and press enter. Or you see there's a number in front of it, the 5. You can simply press the 5. It'll do the down arrow and enter for you. But some manner you got to choose intersect. Now it'll come up in the lower left-hand corner and asks us for first curve. And it says question mark. That's why I put a question mark on these. We're going to do enter on first curve. So there's nothing fancy you have to do. Just simply press enter. And then it'll come up and ask us for second curve. And we simply do an enter on that. So we do enter on second curve. Then we'll input an x value close to your answer and press enter. I think the answer is -5, -6. Let me put -6 in. So I'll type in -6 and press enter. And it'll find the answer closest to your guess. So it found this one. Now our answers are where it crosses the x-axis. Remember the zeros is the same as your x-intercepts. Okay, so our first answer was x equals -4.378. But there's 2 more places where it crosses the x-axis, so I have to repeat the process. You do not have to re-enter your polynomial. It's still in Y1. But I'll do second trace, choose intersect, enter on first curve, enter on second curve, and then I'll put in -1 for the guess. And that's x is equal to -1.167. We have one more answer to get. So I'm going to do a second trace, choose 5 for intersect, enter on first curve, enter on second curve, and I'll put 3 in. Looks like close to 3. Actually, I won't put 3 in. I'm lying to you. When it asks me for the guess, I'll use my right arrow key to move my cursor over closer to the answer I'm trying to find. Now, it doesn't have to be right on top of it. You just got to be over closer to the one you're trying to find. And then you can press enter. Now, that technique is very handy if you're going on to trig or calculus, because sometimes you don't know what those tick marks represent. So we got x is equal to 2.545. And those would be our 3 answers. Grab a drink here. And that's how you find zeros on a TA3, TA4. Okay, let me skip over to the next section, 4.2. And I won't cover all the topics here. I think part of them you can look them up in the book, or watch the examples and you get it easily. But what you may not be able to get easily is the graph. So let's take a look at number 14. This is on page 323. Then we got g of x is equal to x to the 4th minus 4x to the 3rd plus 3x squared. Now the instructions are to graph this. And I'm going to show a couple of these by hand, but if you understand the basic principles, you can also use your calculator to help you get the graph very easily. So let's take a look at this. First off, I want to find the x-intercept. Now to find the intercept, you always plug 0 in the other variable. So to find the x-intercept, we plug 0 in for y. So we got 0 is equal to x to the 4th minus 4x to the 3rd plus 3x squared. Remember, another name for x-intercept is zeros. Now this we want to factor, and I would factor using the GCF. because they all have an x squared in common. So I factor out an x squared, and that gives us x squared minus 4x plus 3. Now x squared minus 4x plus 3, I can factor that using the PSD method. So that factors as x minus 1 times x minus 3. Now the zero factor property. If you got 0 on one side, you factor the other side, you can set each factor equal to 0. So I'll set x equal to 0, I'll set x minus 1 equal to 0, and I'll set x minus 3 equal to 0. So that gives us 0, gives us 1, and gives us 3. Now those are our x-intercepts, but they're also our zeros. 0, 1, and 3. Okay, let's come down here. 0, 1, and 3. So those are our x-intercepts. Now let's talk about our multiplicity. Our multiplicity is whatever power is on these. This one has a second power. These, if I were to put them, have the first power. So x equals 0 has a multiplicity of 2. X equals 1 has a multiplicity of 1. And x equals 3 has a multiplicity of 1. Now where we use that at is that tells us whether it touches or crosses. If your multiplicity is even means it touches. And we'll get back to that, see what in the world that means. It means it touches at the x-axis. Now if your multiplicity is odd, that means it crosses. So these both cross. Okay, so touch, cross, cross. So this is going to touch. This one will cross, and this one will cross. Now another item that usually is handy to find, and it's pretty easy to find, is the y-intercept. To find intercepts, you always plug 0 in the other variable, so plug 0 in for x. Now remember, g of x is the same as y, so we've got y is equal 0 to the 4th minus 4 times 0 to the 3rd plus 3 times 0 squared. And all that drops away and just gives us 0. That's no big surprise. If our x-intercept is 0, then our y-intercept has to be 0 also, because it passes through the origin. Leading coefficient test. If we look at our first term is x to the 4th, which means we're going to have a positive coefficient and we're going to have an even degree. Okay, positive coefficient, even degree. Let's see what in the world that says. Positive coefficient, even degree, that says up to the left, up to the right. And I'll use a little notation they have. So up to the left, up to the right. Well, if I come down here, it's up to the left. So as it goes clear to the left, it's going to go up. As it goes clear to the right, it'll go up. Touches here, crosses here, and crosses here. A real rough graph would look like this. So it's coming down, touching at a point, turning around, coming back up. At some point it has to turn around because it has to come down here and cross. So it's crossing the x-axis, and then at some point it has to turn around and come up here because it has to cross. Now that's a real crude graph. So again, coming down, touching at this point, turning around, has to turn around, or yeah, turns around here, comes up here, turns around at some point, comes back down, crosses there, comes down here, turns around, and crosses here. Now the question we don't know is how far down does this go? I guessed it was right there. How high up does this go? Have no clue. The only way you could find that is if you wanted to do it completely by hand, you'd plug in a test point, x equals 1/2, Might tell you how high up it goes. And you'd plug this into your original function. To find out how low this goes, I'd plug in, this is, I guess, x equals 2. So I'd plug in x equals 2. And that would tell me how low it goes. But we do have the graphing calculator. So if I were to graph this, press y equals clear. I got x caret 4 minus 4x caret 3 plus 3x squared. And then I press my graph. Now the 0 doesn't hurt anything. That's in there from the previous section. But if I press graph, we get this right here. Now you might think that's your graph, but we know that it has to come up a little bit before it turns around. This almost looks like it goes straight across. I could see that better since I found these items by hand and I know generally what it's supposed to look like. I could come over here and I could do a zoom. And the best one to choose is zoom box, in my opinion. So I choose zoom box. Doesn't appear like it's done anything, but now I'm going to do my up arrow and left arrow until you see a little plus appear on your screen. We want to put this in the upper left-hand corner of the box we want to draw. And that's good right there. So I'll press enter one time, and then I'll do my right arrow, and I'll do my down arrow until I put the box around everything I want to zoom in on. And that's probably good there. So if I press enter on that, I see it comes down. It doesn't go up very high, does it? So I was wrong in that regard. I said it went up this high. It doesn't go up that high. It's probably a little bit lower. So you can use a combination of the techniques that I've showed you by hand and the calculator to truly understand what's going on with the graph. Now to set your calculator back, you do zoom, and then you press 6 for Z standard. Okay. Let me pick another problem. Let me clear that off. And I'll pick one that maybe is not so easy to see, so we can use a combination of the by hand and calculator. Let's take a look at number 29. We got f of x is equal to x minus 2 squared and x plus 1 to the 4th. First thing we're going to find is our x-intercepts, which remember is the same as our zeros. You always plug 0 in for the other variables. We'll plug 0 in for y. So we've got 0 is equal to x minus 2 squared times x plus 1 to the 4th. Now it's already factored, so that works out well. We're going to set each factor equal to 0. So I'll set x minus 2 equal to 0, and I'll set x plus 1 equal to 0. So that gives us x equals 2, and x is equal to negative 1. And those are our zeros, or our x-intercept. Now our multiplicity, again, that's whatever power is up here. And this one had a power of 2. And this one had a power of 4. Okay. So they're both even. So in terms of a touching or crossing, they're both touching. So negative 1 and 2. Negative 1 and 2. Here's negative 1. And here's 2. And they're both touching. Okay, now let's see how in the world would I use the leading coefficient test. Well, actually, I'll do the y-intercept first. Jumping ahead. You always plug 0 in for the other variable, so I'll plug 0 in for x. So I got y is equal to 0 minus 2 squared times 0 plus 1 to the 4th. 0 minus 2 is negative 2. Negative 2 squared is 4. 0 plus 1 is 1. 1 to the 4th power is 1. So we'd end up with y is equal to 4. Usually the y-intercept is so easy to find that it's worthwhile going ahead and finding that. So that's right there. Okay. Now, our leading coefficient test. Okay, this would be a challenge because it's not in standard form. Well, what you can do, and this may seem weird, but you take your largest power of x, that term there, and then you raise it to this power. Take your largest power of x here, you raise it to this power. So that would give us x squared times x to the fourth. And you'd have to handle it a little bit differently if you have numbers involved, but it's a different case. X squared times x to the fourth is x to the sixth, which means I have a positive coefficient because there's a positive 1 in front of it, and I have an even degree. Okay, positive coefficient and even degree. Positive coefficient, even degree is again up to the left, up to the right. So I don't know much about it, but I know it up to the left and up to the right. Okay, come down here. I know as it goes clear to the left, it has to be going up. As it goes clear to the right, it has to be going up. It's touching here, which means this has to come down here, touch at this point, turn around, come up. It definitely has to cross the y-intercept here, or the y-axis, I mean. And then at some point it's going to turn around, come down here, touch, and then go back up. Okay, now the question I don't know is maybe how high up this goes. So I might plug in, if I was doing it completely by hand, I might plug in x equals 1 to get an idea of how far up does this go. Probably this is going to give me a pretty good idea right there that this is the angle. But let's see. Let's graph it on the calculator. Okay, so I got y equals clear, and then x minus 2 squared, and then x plus 1 to the fourth power, and then graph. Okay. So you can see it's passing through here, and it's going way up there. You know, I almost immediately had to turn around, but it looks like the graph is going way up before it turns around. So it's actually more like that. If I were to zoom out, that's another zooming technique. If you press zoom and choose 3 for zoom out, and when it comes back, you press enter 1 time. Sometimes it gives you a good graph, sometimes it doesn't give you anything. This is horrible. But I could now do a zoom box. If I did zoom box, and I press and hold down to move that up, and then I move to the left like that. Press enter on that, then down arrow, and you can hold down on it to very quickly move and go over. Once you get your box around what you want, you press enter. Okay, that gives me a little bit better picture of what it looks like right here. So yeah, I wasn't even close there. You could also use your min and max function, which we looked at in class, to find out how high this goes. So if I wanted to see what the highest point was here, you do second trace, choose your maximum, because we're trying to find the high point, so I do 4. It'll come up and ask us for left bound. And I want to move my cursor over closer. I don't want it to be too far away from the max, but I want it to be the left of it. Press enter 1 time. Comes up and asks us for right bound. We do our right arrow key to move the flashing cursor to the right of where we think the max is. Press enter, and then you press enter one more time. And tells us our max is 1, 16. I'm not even close to 16 on this. This is 1, 2, 3, 4. I did like 8, so it really has to go up to 16. So again, you can use a combination of the by hand techniques and your calculator to understand what's going on with the graph. And really, it does take a combination of both of them unless you're really good at your calculator to understand what in the world you're seeing. Now remember, to set this back, we do zoom, and then we choose 6. Let's take a look at 4.3. This is polynomial division. And trying to find polynomial division. I guess number 6 would be polynomial division. This is on page 331. So let me clear that off. And it tells us that p of x is equal to 2x to the third minus 3x squared plus x minus 1, and d of x is equal to x minus 3. Now they tell you to write it in a little bit different form in the book, and I'm not sure what the online homework will do. And I'm only going to show you one example of this, which may not be enough. So if you need to see more examples, and as you're working the homework, feel free to click that button that says Ask My Instructor, and I'll work whatever one you click. Okay, so for our long division, we set up in this form. Now, these have to be in standard form. So they have to be arranged from largest power down to smallest, which they both are. And you can't have any missing powers. If you have any missing powers, you have to put 0 placeholders for it. And I'll do another setup after this just so you see what in the world I'm talking about. Now, to decide what goes up on the top, you only look at the first term of each. So you ask yourself, what times x gives you 2x to the third? And that would be 2x squared. Now, whatever you put up on top, you're going to multiply by what's out in front. So we're going to take 2x squared times x minus 3. 2x squared times x is 2x to the third. 2x squared times negative 3 gives us negative 6x squared. Now we're going to subtract that line, which means we flip signs. So this one becomes negative, this one becomes positive. 2x to the third minus 2x to the third drops away. Negative 3x squared plus 6x squared gives us 3x squared. And then I bring everything else down. Now again, we look at the first term of each, decide what goes up on top. We ask ourselves what times x gives us 3x squared, and that's 3x. Now remember, whatever you put up on top, you're going to multiply by what's out in front. So I'll take 3x times x minus 3. 3x times x gives us 3x squared. 3x times negative 3 gives us negative 9x. Now we're going to subtract that line, which means flip signs. So this becomes negative, this becomes positive. 3x squared minus 3x squared drops away. X plus 9x gives us 10x. And then I'll carry down to minus 1. Now again, we only look at the first term of each, decide what goes up on top. So you ask yourself, what times x gives you 10x? And that'd be 10. Now whatever you put up on top, you multiply by what's out in front. So I'll take 10 times x minus 3. 10 times x is 10x. 10 times negative 3 is negative 30. Now we're going to subtract that line, which means flip signs. So this becomes negative, and this becomes positive. 10x minus 10x drops away. Negative 1 plus 30 gives us 29. Now remember the degree from the earlier section. We said your degree is your largest power of x. The degree of 29 is 0. There is no x. The degree of x minus 3 is 1. When the degree of whatever's down here becomes less than what you're dividing by, this is always your remainder. And what I'm used to writing it out as is you put your remainder over what you're dividing by. So we put the 29 over x minus 3, and that would be our answer. The book wants you to write it a little bit different. They want you to write it as your d of x, which is x minus 3, times whatever's on top, which was the original 2x squared plus 3x plus 10, plus your remainder, so plus 29. So that's how the book specifically specifies it. I like this form the best, but again, it's the online homework, the form that they want you to enter it as. Now I'm not going to actually work this problem, but let me show you the setup. All of these are in standard form, so that doesn't do any good. But let's look at the setup on number 10. We got p of x is equal to x to the fourth plus 6x to the third, and d of x is equal to x minus 1. So I do x minus 1, then I'm going to have x to the fourth plus 6x to the third plus 0x squared plus 0x plus 0. Remember I said these both have to be in standard form, terms range from largest power down to smallest, and you can't have any missing powers. So this one was x and then no x, our constant term. Here I started with x to the fourth, so I have to have an x to the fourth, I have to have an x to the third, x squared, x, and no x, our constant term. So these missing powers at the end, I put a 0 placeholder here. Now what you'll find is, I'll just do a little bit of this, as you go through and multiply these together, you're going to find that the like terms will always line up in the same column. X to the fourth minus x to the fourth, this gives us 7x to the third. And then I got 7x squared here. I should have brought everything down. I was taught division to bring everything down, and it's like a brand new problem you're looking at each time. And you make less mistakes that way. Whether that's true or not, I don't know. Okay, that's probably enough to demonstrate it. Notice as I was going down, x to the fourths line up, the x to the thirds all line up, the x squareds line up, the x's line up, and the no x's line up. That's what the 0 placeholders accomplish, and putting it in standard form. Okay, let's take a look at synthetic division now. And let's take a look. This is on page 331, number 11. So we got 2x to the fourth plus 7x to the third, can't hardly read that, plus x minus 12 divided by x plus 3. Instructions say use synthetic division to find the quotient and the remainder. So this is synthetic division. Your first step is you take what you're dividing by, which is x plus 3, and you set it equal to 0. So you always take what you're dividing by, set it equal to 0, and you want to solve it. So I take the 3 over, and it becomes a negative 3. Step 2. We want to take the number we just found, we want to put in a box in the upper left-hand corner. So again, whatever number you find right here, you're going to put in a box in the upper left-hand corner. Now we identify our largest power. Our largest power is x to the fourth, so real small across the top. We want to start with x to the fourth, and then we want to have 1 for each power going down. So we'll have x to the third, x squared, x, and our no x, our constant term. Now we want to write down a number that's in front of each one of those. The number in front of the x to the fourth is a 2. The number in front of the x to the third is a 7. There is no x squared, so we have to put a 0. The number in front of the x is a 1, and the no x, the constant term, is negative 12. Okay, now we're going to go through a series of adding, multiplying over and over until we're done. You want to start with the first column here, and we got 2 plus nothing, which gives us 2. Now sometimes that throws students. They say, well, what do you mean nothing? Well, there's nothing here. But if it does throw you, it really is simple as bring the 2 straight down. So I know nothing's simple until it actually clicks with you. Then we're going to multiply. You always multiply the number up in the box by the number you put down on this line. So negative 3 times 2 is negative 6. Then we want to add. 7 to negative 6 gives us 1. Then we multiply. You always multiply by the number up in the box by the number you put down here. Negative 3 times 1 is negative 3. Then you want to add. 0 and negative 3 is negative 3. And then you want to multiply. You always multiply by number in the box, by number you put down here. Negative 3 times negative 3 is 9. Then you want to add. 1 plus 9 gives us 10. And then you want to multiply. You always multiply by number up in the box, by number you just put down there. So we'll take negative 3 times 10 gives us negative 30. And then you want to add. Negative 12 and negative 30 gives us negative 42. Okay, so let me double check this. Been a long day. Make sure I added and subtracted and multiplied right. Okay. Now this was x to the fourth. Straight down below here will be 1 degree lower. So this will be x to the third. Now once you have your first one, then you have 1 for each power going down. So this will be x squared. This will be x. This will be no x. And this will be a remainder. And I would write it as 2x to the third plus x squared minus 3x plus 10, and then you put your remainder over what you're dividing by. So I'll put the negative 42 over x plus 3. Some books, if you have a negative here, they'll put the negative out in front. Some books will put it up on top. The ones that put it up on top want to really emphasize that your remainder is a negative 42. And you might overlook that if you put the negative out in front. It doesn't matter how you do it, but different books do it different ways. And that's synthetic division. Okay. Let's look at, I'm not going to do all of them, but I'll just do part of number 23. And they say use synthetic division to find the function values. So we got f of x is equal to x to the third minus 6x squared plus 11x minus 6, and we want to find f of 1. This is officially called the remainder theorem. And let's go ahead and do synthetic division, and I'll tell you what the remainder theorem tells us. Now when I say do synthetic division, let me shut the window so you don't hear that train yard. I don't live right next to the train, just sounds like it. When you're evaluating a function, whatever number that you're evaluating for, so whatever's inside the parentheses here, is what goes in your box. Okay, now our largest power is x to the third, so real small, I'll write x to the third, x squared, x, and no x. And I'll write down a number that's in front of each one of them. There's a 1 in front of the x to the third. There's a negative 6 in front of the x squared. There's 11 in front of the x. And no x is negative 6, the constant term. Now we want to go through and do a bunch of adding and multiplying over and over until we're done. So we'll add first. 1 plus nothing is 1. Or you could just simply take this, bring it straight down. And now we're going to multiply. You always multiply by number up in the box, by number you put down here. 1 times 1 is 1. Then we want to add. Negative 6 plus 1 is negative 5. Then we want to multiply. You always multiply by number in the box, by number you put down here. 1 times negative 5 is negative 5. Then you want to add. 11 and negative 5 is 6. And then you want to multiply. You always multiply by number in the box, by number you put down here. 1 times 6 is 6. And then you add. Negative 6 plus 6 gives us 0. Well, let's evaluate it like we have before. F of 1, when you evaluate a function, you put 1 in everywhere you have an x. So I got 1 to the third minus 6 times 1 squared plus 11 times 1 minus 6. 1 to the third is 1 minus 1 squared is 1 times 6 is 6 plus 1 times, or wait a minute, that's 11. 11 times 1 is 11 minus 6. That gives us negative 5 plus 11 minus 6 is 5. And negative 5 plus 5 is 0. Now our answer is 0. The remainder theorem says you can evaluate polynomial functions using synthetic division by taking the value you're going to evaluate, plug it into your box, and then whatever your remainder is happens to match what your answer is. So instead of doing it the old way like I did right here, you could use a new way of doing it, the remainder theorem, and then whatever your remainder is your answer. Okay, let me grab a drink and then we'll take a look at the next one. Okay, let me clear that off. And we're going to look at 31. We got negative 3 and 2. And we got f of x is equal to 3x to the third plus 5x squared minus 6x plus 18. Now the instructions say using synthetic division determine whether the numbers are the zeros of the polynomial function. Well, what that says is we're going to plug our first potential answer, negative 3, into synthetic division. Now our largest power is x to the third, so real small across the top, I'll write x to the third, x squared, x, and no x, our constant term. The number that's in front of our x to the third is a 3. The number in front of our x squared is 5. The number in front of our x is negative 6. And the constant term, the no x, is 18. Now we'll add, multiply. You always multiply by a number in the box, by number you put down here. Negative 3 times 3 is negative 9. Add. 5 and negative 9 is negative 4. Multiply. Negative 3 times negative 4 is 12. Add. Negative 6 plus 12 is 6. Multiply. Negative 3 times 6 is negative 18. Add. 18 minus 18 is 0. Now there's something called the factor theorem. And it's very specific that what I'm going to write is not quite what the book would write as a factor theorem, but what I'm going to write is very specific to this process that we're in the middle of right here. If you've gone through and you plugged in a number in a synthetic division, testing to see whether it's a 0, factor theorem says if your remainder is equal to 0, then you find an answer. Now another name for answer is 0. So that means you found a 0. So the fact that we came up with 0 as a remainder right here means that negative 3 is a 0. Okay, they also want us to check 2. So I'm going to plug 2 into synthetic division. And I'll go a little bit faster. I'm thinking maybe, hopefully, you have synthetic division down. So I'll add, multiply, add, multiply, add. What is that, 16? Multiply and add. And notice what we came up with here. Our remainder is not 0. We came up with 50, assuming I added and multiplied correctly. Now that tells us that 2 is not a 0. So again, that's how you determine if a given number is a 0, is whether you come up with 0 as your remainder. Sounds weird. I don't know why they don't call it the 0 theorem. But factor and 0 are actually very closely related. Okay, let me clear that off. And let's look at number 39. So we got f of x is equal to x to the third plus 4x squared plus x minus 6. The instructions say to factor the polynomial. And then it says solve the equation. Interesting instructions. Okay. It's actually easier to solve it first and then factor it, but we'll go with that. Now we're going to use a calculator to solve it. Now when I say solve it, we're going to set it equal to 0. Solving it basically means find your zeros. And we looked at this on the calculator in the previous section. So we're going to put this into the calculator. I'll press my y equals, press my clear. I got x to the third, so I'll do x caret 3 plus 4x squared plus x minus 6. You still have to have 0 on y2, so if you don't have that there, then go ahead and put a 0 there. Now do second trace, choose intersect. And I can't see that real well. Negative 3, negative 4. Anyway, it's asked us for first curve, so I'll do inner on first curve, inner on second curve, and let me put in negative 4 for the guess. And comes back and tells us our first answer is negative 3. Okay. Now let's find our second one. Probably negative 2 if I had to guess. So I do second trace, choose intersect, inner on first curve, inner on second curve, and we put negative 2 in. And it comes back and tells us negative 2. I was pretty sure it was negative 2 because I could see it coming up a little bit above the x-axis, coming back down. If I look at the larger screen, you can see it's coming up and then coming back down, so negative 3 and negative 2. Now this last answer looks like 1. So if I do second trace, choose 5 for intersect, inner on first curve, inner on second curve, and I'll put 1 in for the guess. It comes back and tells us the intersection is x equals 1. Now, as strange as it sounds, that's an answer to the second part where it says solve the equation. Okay. Now we want to factor it. Let's see how in the world we're going to do that. After you come up with your answers, if you move this on the same side as the x, so move that negative 3 over, move that negative 2 over, and move that 1 over, we're going to get x plus 3 is equal to 0. We'll get x plus 2 is equal to 0. And we'll get x minus 1 is equal to 0. When you take anything across or equals, the sign changes. Now we're going to put parentheses around each one of these and put them next to each other. So I got x plus 3 times x plus 2 times x minus 1. That would be the factored form of our function. So that's how you'd factor it after you solve the polynomial. And that's actually the end of that section. I don't see anything else really meaningful there. Again, I haven't gotten a whole lot of depth on these, so if you struggle with any of the problems, click the Ask My Instructor, and I'll work it in the YouTube video like you're seeing right now, and I'll send it back to you.